So hello everyone. Today I'll be telling about the interfacing of LCD and keyboard to the 8051. Before starting with the interfacing, I'll be using a simulator for 8051. Fine. So that when we study the interfacing of various unit with the microcontrollers, it would be very difficult for analyzing its program, because the programs are very lengthy and it's very difficult to analyze that the flow of programming. It's very difficult to analyze the flow of programming. So what I'm doing, I'm using a simulator. The name of the simulator is Edsim 51. It's a freeware and it's such a good simulator. It consists of all the interfaces ready-made. All the interfacing devices like LCD, LEDs, switches, they all are already connected to 8051, and you just need to run your program and those interfacing devices will run. Fine. So LCD and keyboard are also available on that. So let's first view the Edsim 51. This is the view of Edsim 51. Now this Edsim 51, this is the interface of Edsim 51. The Edsim 51, here you can give the system clock. You can give your own system clock, and you should know that what is the limit. So for 8051 the limit is 24 megahertz. Fine. So starting from any frequency till 24 megahertz, you can put the frequency which you wanted to give to 8051. Fine. Now these are the resistors for timers. If you wanted to do timer programming, then you can provide the values in the timers register. Fine. These are the general purpose resistor R0 to R7. Fine. And this is the program status word, the 8 bits of program status word, where which will give you the status of arithmetic and logical operations. Fine. Which consist of carry flag, auxiliary carry flag. See, if you put a cursor on this, it will show you that what does this bit of each PSW mean. If you are not able to see, let me show you with a magnifier. Just a second, it takes some time. So if you focus on this key C, for the PSW, first bit it shows it as a carry flag. On the second bit it shows a auxiliary carry flag. On the third bit it is shown as a flag 0. See, in many theory classes we might have not studied. We have studied that this bit is not used, although some machines or some 8051 based microcontrollers like Admiga, they uses this bit as a flag, general purpose flag, which we can set and reset whenever it is required in the programming. So today also we'll see that this flag is utilized. The fourth one is RS1 and fifth one is RS0. We all know this. This RS1 and RS0 is used to select the register bank in the RAM, and this is overflow flag. This is one means this is not used, and the last one is parity flag. Fine. So all I wanted to make you clear that how powerful this simulator is. Fine. This simulator is powerful also, as well as user friendly. So see, as a student or as a faculty, we should know what is PSW and what are the different bits of PSW. But if we don't know, or if a user, a layman doesn't know, then he can just go to the PSW each bit and can know what does this bit mean. Fine. So after the arithmetic operation, what we will do here, it will be updated automatically. Fine. So let's come back. So this is PSW flag. So you can see the result of PSW directly here. Now this is the receiver and transmitter bits. Fine. This is the serial control flag, serial control register. Fine. And this is the frequency of result. See, when the program is executing, then you can dynamically select that at what rate you wanted to execute the program. So powerful that if you wanted to execute the program at 1 hertz, then also that means 1 hertz means you can select 1 hertz as for the this 12 megahertz with respect to this 12 megahertz. This is not exact 1 hertz, it is 1 unit frequency with respect to 12 megahertz clock, fine, or whatever clock which you are giving here. So you can decide that at what rate your program execution will happen, because sometime if you wanted to debug a program, you wanted to see each step of program executing, then you select a lower frequency, or otherwise if you just want result, you can select a higher frequency, fine. It's very easy. Now some special purpose registers are also given here, which stack pointer. So hexadecimal values are given here: stack pointer, data pointer low, data pointer high, program control register, interrupt enable register, interrupt priority register, program status word can also be seen here, accumulator and B register, fine. So all these registers can be seen from this much area, fine. So apart from this, you can also view the data memory as well as the code memory inside the RAM, inside the 8051. This is the data memory which is in front of you, fine. This is shown, the content of the memory are not shown as a bits, but they are shown as a hexadecimal value, fine. So that means your memory will start from 000, because the data memory is only 128 bytes. We all know that your user has only access to 128 bytes of RAM, fine. So it start from 000 to 70F, fine. 00, I'm again repeating, 000 to 70F. So 000 means first row and first column. So 000, it starts from here till 70F, till here. So your entire memory, the content of the entire memory can be seen here. And also if you wanted to provide some write something into the RAM, so that your program can take that value in from the RAM, then you can directly give the address here, that at what address you wanted to give a value. For example, I wanted to write something at 6000, fine, 6000. At this address, if I wanted to write something 6000, and if I wanted to write a value, so you can put any value from here. For example, if you wanted to put a value at this location, for example at this location, what is this location? This location is 64, 60 plus 4th location, that is 64th location. So if you wanted to put something at 64th location, then you can put directly give the values. For example, if you wanted to write just say 0A, fine, just put the enter and it would be stored at the 64th location, fine. So how many locations you have? 128 locations. These are all those 128 locations, starting from 00, this is 00, this is 01, this is 02, 03, 04 till 0F, then 10, 10, then 100, like this till 70, 71, 72 till 7F. 7F is how much? 128 bytes, fine. This is how your data memory has been shown to you. Now you can switch between data memory and code memory. See, code memory is not in our hands. We cannot edit the code memory. We can put our code here. This is our code section. So we can put the code here. That code can be viewed in the code memory. Just click on this button and code memory will be shown to you, fine. So whatever code which you are writing here and saving into the code memory, it will be saved in the code memory. Instead the provision has been given. See, you can directly edit the code here, but it's not recommended because it's the hexadecimal code and you won't be able to understand the hexadecimal code. Instead, the direct assembly language code can be entered here. And also there is a provision of entering the embedded C code here. You know, the 8051 can be programmed in two ways, by the embedded C code or maybe with the assembly language. So today we'll use the assembly language program, but the embedded C code can also be assembled with this simulator. Fine. So this is the data memory, and this you start writing your code here. Fine. Once you write the code, you assemble the code. Assemble means each line of the code would be converted into the machine language, and it would be saved onto the code memory. Fine. For example, I have a code written here. Fine. So when I assemble the code, see, a particular location in the code memory would be assigned to each line. Fine. So what happened? This entire code converted into machine language, and it's saved onto the code memory. This is the code memory. This code memory is entirely filled. You can see this code memory is entirely filled, and this code memory is filled with what data? This entire code. Fine. And then you can run the code. We'll do it. One very important thing which you can see here is this one. I'll tell you with the magnifier, so you can see it more clear. So look, this one. Yeah, this is the oscilloscope, the digital to analog converter, the digital to analog converter oscilloscope. So it's similar to the CRO which is available in the labs. So what happens here, you write a program where you give a digital value in digital values like hexadecimal values, and those would be converted into analog form using a digital to analog converter which is connected or interfaced to 8051, and then that the value which is converted by digital to analog converter will be an analog value, and that would be shown in this oscilloscope. Fine. Then you have this switches. These are switches. These are simple binary switches. When you put on this switch, it will conduct, and when you put off the switch, it will not conduct. So these are simple binary switches. These are LEDs. You can see these white color. These are LEDs. Fine. So these are LEDs are connected to a particular port. So when you send a data from on that port, these LEDs will glow. It's very easy. Fine. I'm again repeating, when you send the data as a logic 1 to that port, so this LED will glow. Fine. Then you have a this is hex keypad. We call it as a hex keypad, although it looks like a num keypad of a landline phone. Fine. So it is designed something like this, but it is a hex keypad, and this hex keypad, today we'll study how to enter the data through the hex keypad. Fine. And 3 versions of hex keypad are available. I'll explain you what are those 3 versions. Then a UART is also available here, where if you receive something into the receiving pin, the serial receiving pin of 8051, that will be displayed here, and when you transmit serial data from the 8051 from the transmission pin, the TX pin, that will be displayed here. Fine. And at what rate, if the rate also you can select. Fine. At a higher baud rate, lower baud rate, more lower baud rate. I need not to explain you what is baud rate, because at this level you might be knowing what is baud rate. Then very good thing and a very important and a very powerful thing with this tool is analog to digital converter. We have seen the digital to analog converter. A digital to analog converter was already available here, and a analog to digital converter is also available here. What does it mean? If I wanted to interface an analog to digital converter with this 8051, then I need to give analog input to that analog to digital converter, right? The analog input can be given from this interface. See, if I put it on lower value, this is 0 0. If I increase it, it increases to 1.39, 1.5, 1.6 till 5 volt. What is this? This is analog value, analog voltage. So I am giving it input as an analog voltage, where I am giving the input to the analog to digital converter. This is analog to digital converter. Fine. So I'm giving input to the analog to digital converter. It will be when we'll write the program for conversion, it will be converted to digital value, and wherever we wanted to display the digital value in the register or wherever, it would be displayed. Fine. Then you have a motor. This is a DC servo motor. A DC servo motor is here, although I'm sorry, it's not a servo motor, it's a stepper motor. So a stepper motor is also here. So we'll do that programming also, that how this stepper motor has been connected to 8051 and how it is programmed. Fine. So let us come back, and you can see through the magnifier. See, the fonts are very small, so it's very difficult for you to see, so I've used a magnifier. So in the magnifier you can see that this is the portion where you write the code. Fine. So let us come back, and one more important thing which I wanted you to see. One more important thing is this one, LD and DI. See, this is just the interface. This is just the interface. Internally, all these modules, this module, this module, this module, all these modules would be connected with the wire to 8051. So we need to see that which ports are connected to ADC, which ports are connected to LED, which ports are connected to motor. Fine. So for that you have the logic diagram here. Just click on this logic diagram and a logic diagram will open in front of you. This is the logic diagram. This is the logic diagram. Just a second, let me make it visible for you. Yeah. So this is your logic diagram. This is your 8051. You can see this is your 8051. Now you can see the port P1. This is port P1, this is port P0, this is port P3, and this is port P2. So all the 4 ports have been shown to you, that where these ports are connected. Fine. All your interfacing devices are connected to these ports. Practically also you connect your motor, your ADC, DAC, hex keypad, LED, all the interfacing devices to these ports only. Fine. So port P0 is connected to the hex keypad. You can see the port P0 is connected to hex keypad. How it is connected to in today's lecture we'll see how it is connected. Fine. Port P1 is connected to LCD module. Fine. And it is also connected to DAC, digital to analog converter. Fine. The port P2 is connected to analog to digital converter, ADC, you can see, and it is also connected to the switches, various switches. See, this is simple binary switch. When you close the switch, it is connected to 0, logic 0. See, it's ground. If you're not able to see, I'll use a magnifier. You can see. So where are the switches? These are your switches. See, your switches are connected to ground. So when you put on the switch, a 0 will be available at this pin. Fine. That means the switch. Just a second. So this was port switches. Switches are connected to port P2, and with port P3 the 7 segment display is connected with port P3. Fine. So this is the logic diagram connection of 8051 and various interfacing ICs. It looks very complex, but see, you can simplify it. How? Just see. There's a provision that you can select one at a time. I'll show you how. Just a second. See, at the left hand side you can see all the modules have been shown to you. Fine. You just put deselect all. Now there's no connection. This gray color means there are no connections. Fine. Now you can select any one module. For example, if you wanted to see the connection between 8051 and today we'll do the LCD module, so you wanted to see the connection between LCD module, just select the LCD module, the connection will be shown to you. Fine. So your port P1, how your port P1 and which pin of the port P1 is connected to which pin of LCD module, it is shown to you. Fine. It's so easy. So this is about the logic diagram. The other functionality of this Edsim 51, let's see. Yeah, this DI is dynamic interface. Dynamic interface, here you can change your logic diagram also. You can change your complete connection. Since this 8051 has already been connected, which I have shown you, you can also change your connection according to you. If you wanted to use only LCD module and remove other modules, you can do that. And by, for example, here you can choose that which port you are talking about, and with that port what you wanted to do. For example, keypad row 0, this is what hex keypad, the 4 rows of hex keypad. Today I'll explain what does it mean. The 4 rows of hex keypad, if you wanted to join it to port P2, you can join it. By default it has been joined to port 0, but if you wanted to change these connections, you can change this connection dynamically also. So how powerful this simulator is, you can see. Fine. Now you write your program here and assemble it. Let's see one of the program. I have a program of LCD module. I'll explain that program. First, I just wanted to make you see one sample program. So I have a LCD program. What this LCD program does, it writes yes onto the LCD. We have this LCD. This acha, I will not explain to you about LCD. This is a 16 by 2 LCD. That means you have 2 rows of 16 characters, 2 rows of 16 characters. So each row can accommodate 16 characters. Fine. So these characters YES, yes, will be displayed on to these area of the LCD. Fine. So just assemble it. It is assembled. Assembled means a particular program, these instructions are saved onto this program lines inside the program memory. Now you run it, and you can dynamically select the frequency also. Fine. For example, I have selected a very low frequency, 10 units with respect to 12 megahertz. Fine. And run this program. So you can see the currently nothing has been displayed. See, it became red, Y has been displayed, then this became red, E has been displayed, this became red, Y, S has been displayed. See, so easy it is. Pause this, reset it, everything would be resetted. Let's see the same thing with a magnifier. I have to use magnifier again and again because fonts are very small. Run the same program again. Let's see. It is still gray. It became red. Y has been displayed. Second place became red. E has been displayed, and now S has been displayed. Fine. This was very slow. With the speed of the 12 megahertz, if you see, just yes would be displayed instantaneously. Let's see. With the full speed is this much. If you go with the full speed, assemble it and then run it. So I have to reduce the magnifier. So just run it. When you run it, immediately yes would be displayed here. Fine. With the frequency of speed of 12 megahertz. Fine. So this was a sample program just to see you that how Edsim 51 is looks like. Fine. Now we'll see that how the LCD can be interfaced with 8051. Fine.